Hello and welcome back to Math with Shinrai Sensei. And today we're going to be covering some basic algebraic expressions and equations to kind of get you familiar with algebra and give you a basic understanding. We've already covered the order of operations, and to basically cover it again, if you have a variable, substitute a value in for the variable if you have the value, right? But if you don't have the value to substitute, then just operate after, follow the rest of the orders. Next, you simplify anything that's within the parentheses. Then you simplify exponents. Then you do your addition and subtraction from left to right. Then you do your multiplication from left to right, right? So for this instance, first expression we have over here, 7x plus 8x minus 9x. Since all of the constants are being multiplied against the same variable, which is x, we can just do the math like the variable's not even there. 7 plus 8 minus 9. We can do the math from left to right. So 7 plus 8 is 15, minus 9 is 6. And then the x stays the same because the x is, in this case, more constant than the numbers are. It's the only thing that's going to remain exactly the same no matter what the operation in between is, because the variable is the same for all of these, right? Now we have 9x times the parentheses of 8x minus 7y, close parentheses. And in this case, you transfer the 9 into the parentheses, and you go 72x minus 63xy, because now the multiplication problem features both variables. For the 7y right there, it's now 9x times 7y turns into 63xy, right? Now this one gets to be a little trickier at the same time as it's a little simpler, right? So in this instance, we have 12a plus 6b minus 8b plus 9a, right? Well, we have to do something where we change subtraction into adding the opposite so that we can now use the proper property to change the order of the addition and subtraction here. Since now it's adding the opposite, it's now addition. We can't change the order of subtraction, but we can change the order of addition, right? So now we have 12a plus 9a plus 6b plus negative 8b, which comes to be simplifying that down turns into 21a plus negative 2b. That's the simplest version of that. So that turns into that. Now really you could have just gone with 6b minus 8b and just done that and gotten negative 2b as well to simplify that down. You didn't necessarily have to change the addition into subtraction, the subtraction into addition by adding the opposite. But in order to change the order of the numbers and their variables here, you have to be able to have all of these be addition, right? And if they're not all addition, then you can't change the order. Once again, yes, you could have simply gone another route here and simply gone with 12a plus negative 2b plus 9a, and then you'd have had to reorganize it as such, and you'd still get to the same conclusion, but this is just one less step depending on the situation. It really is totally situationally dependent which is easier. And sometimes you can't you can't just do the subtraction. Sometimes you have to change the subtraction into addition in order to readjust the expression into an order that you can actually work with, right? But for the purposes of this, either one of these is possible. But if I was subtracting, let's say the 6b was being subtracted from the 12a, and let's say I had other variables thrown in here that perhaps there were no like variables to the subtraction problem. There were no like variables for that negative number. Now, so let's say, better example to write this out is if I had 12a minus 6b plus 8c plus 9a, right? Well, now I have to change this into addition of the opposite in order to change the order because now this isn't a matter of two like variables, which I can actually simplify down already. Now there is no like variable to subtract that from, so I have to have it as adding the opposite in order to keep all of these operations as addition and change the order, right? But they have to have like operations of addition, specifically addition, to be able to do that, right? Now, let's go ahead and we'll simplify these equations down, right? Or we can solve the equation and find the number that the variable is. So, I'm going to go ahead and erase some of this so that I can have a bit more room to work with. There we go. That way I can keep the correct answer on the board for this one. Now, 7x plus 12 is equal to 26. Well, you subtract 12 from each side, and that leaves us with 7x is equal to 14, and you divide each side by 7, and now x is equal to 2. Right? Now, some math teachers will say add the opposite, so adding negative 12, but that's the same thing as subtracting. And if you don't have to make it more complicated by saying something like adding the opposite, then don't make it more complicated. Subtraction is something everybody knows, everybody's familiar with. You don't have to use adding the opposite. You can just say subtract 12 from both sides. All right? And so x is equal to 2 for this. So x equals 2 for the first problem, right? And that's how we solve for it, right there. Hopefully you can see that through the glare. And I have the new curtain rod, so you guys are aware we'll be putting it up. All right, now let's solve the next equation, which is 8y plus 6 equals 38. Well, once again, you subtract the 6 from both sides, which leaves 8y on its own is equal to 32. Then you divide 8 into each of these. And now you get y is equal to 4. Try it. Really difficult to show you guys without the glare here. But yeah, you can kind of see that. So y is equal to 4 because you subtracted the 6 from both sides, which leaves you with 8 times y is equal to 32. Then you divide both sides by 8, which makes it y on its own is now equal to 4. Right? Pretty simple, pretty straightforward. And now the simplification, or in this case the solution, is y equaling 4. Now, let me erase this real quick. Now in this case, we have 9z minus 7y equaling 8y. Well, in this case, you you only have the capability to simplify because there is two variables and you don't have a value to substitute in for either one, and the answer is only, the answer's also got a variable in it, the equals, I should say. So the equating part of this, where there's no operation other than the variable there, is going to be, I'm very poorly explaining this. Simply put, there are two variables in this equation, and when there are two variables in equations, really the only option you have is to simplify them, unless you are given a value to substitute in for either variable, right? So in this case, you're just going to add the 7y to both sides, which turns this into 9z is equal to 15y. So the simplification here, 9z is equal to 15y. You can only simplify because there are no variables there are no values to substitute in for a variable to give you an ability to possibly answer this. So if I had like 2 was the value for y, or 5 was the value for z, right? Then I could possibly solve this, but I can't solve this unless I know one of these two variables. Because we all know 9 and 15 are not 9 and 15 are not the same. So z and y cannot be the same value. But there is an infinite number of possibilities as to what they could be, because you have numbers stretch on to infinity, 1 and 2. Just because you could substitute 15 in for z and 9 in for y to give you the simplest answer doesn't mean that that's what the values are, right? So z and y are unknown completely, and that's as simple as it can get. So sometimes you are just simplifying when it comes to having too many variables in it. When it comes to having 2 or more variables in an equation, you're only ever going to be able to simplify. But in an expression, unless you are told a value, you can never simplify down to a single number, right? Because so long as there's a variable in an expression, there will remain a variable in that expression if there's no value to substitute. Whereas in an equation, even if you're not given a value for the variable, if there's only one variable, you can usually solve this down and answer for the variable. But if there are 2 or more variables in an equation and you're never given a value for either one, you'll never be able to simplify it down to solve for the variable. So this is some basic introduction to algebra, and I will hopefully be able to give you guys some more examples and stuff like that. Please, if you have questions, leave them down in the comments section. I will do my best to get to your comments and answer any questions that you have. But for today, I think that's where we're going to leave it. Algebra gave you some basic examples, showed you exactly how to solve or to simplify in order to get to an answer that is simpler for the purposes of writing the problem, right? Maybe not necessarily simpler in the purposes of solving it when you do find a value for the variable, but simpler for the purposes of looking at it. It's much simpler, right? That's basically what you're trying to do whenever you have variables. And before you know the values, if you don't know the values, you're just trying to make the you're trying to make the problem as simple as possible, so that when you do know the values, you can just plug and play, right? So once again, basics of algebra. Keep that definition in mind. It's simplifying or solving for variable or variables. That's why the S is in parentheses. It's to indicate that there's a possibility that there could be multiple, but that's not a guarantee that there are multiple. Sometimes there's only one variable. So I look forward to seeing you guys in the next one, and please leave your comments and questions in the comment section.